Recently, I went down a rabbit hole of voice services. If you're of a certain vintage, you probably remember some messages on the phone network. One of them might have sounded like this.
We're sorry. The number you have dialed has been disconnected or is no longer in service. Please check the number and try your call again.
Remember that one? I do. As I was working on the war dialing demo for VCF Midwest in September, I got things working generally, but I kept having this feeling that it didn't feel, I guess, authentic. It wasn't quite the experience I remember on the phone network back in especially the 90s. And I realized, those voice messages that you'd get once in a while when things wouldn't work from the phone system just weren't present. So I went down, as I said, a rabbit hole down this ISR path, the Cisco router and voice messages, to try and get this demo to sound a little more authentic. So today I'm going to go through what I've discovered, what I did, and how I got that message hosted on a Cisco router. There'll be more war dialing stuff coming up in the future. I might end this video with a little bit of a sample from it. We'll see how it goes. But where do we start? The message itself. The voice of Pat Fleet. That was the person that we all remember the most with those messages. She was the voice of the Bell system for, I don't know what, 20 plus years. I guess she still does voiceover activity work, but it was what we remember. A friend sent me this link to an asterisk archive of all of these messages from Pat Fleet from the phone network to be used. Unfortunately, they were all in a format that the Cisco router cannot handle. In my case, a 3845 is what I have now. These are all in ULAW. They need to be in the Sun Next AU format. Mono 8 kilohertz, I think. So step one was, okay, how do I convert these from ULAW to AU? Which means I had to have a utility to do it. So what did I do? Let me grab this window here. I guess let me back up. I spun up a GitHub repo for all of this, which I'll include in the description. All of these utilities and everything that I've discovered and done is up in this repo that we're going to go through, that I'll keep referencing here. But where do we start with the AU files? So we got ULAWs. How do we convert them? Well, let's start with the convert files. Put together a little shell script. You give it an argument of either WAVE or AU as the output, and it takes the input AU, then uses SOCKS, which you need to have SOCKS installed, either under WSL, which I'm using here, or under my Linux box, which I use elsewhere. Either one works. And this will take it and produce a directory structure of all of the AU files that came inbound from the ULAWs. And if we look at, there are some various disconnected messages, which you can then play these and see what they sound like. All right, so now we have an AU file that we can host in the Cisco router. How do we do that? Well, let me switch over to another window here with PuTTY. I am on my 3845 here. Let's do a show version. I am on iOS 15.1.4. And if we do a show hardware, where is it? Here we go. That is what it is. So step one is to get the audio file on Flash. In my case, what I'm doing on Flash is I have two directories. I have one called apps and one called audio. In the end, I want this to be a voice XML app that when you call a phone number on the router, the voice XML app plays the audio file. It's really that simple. And let's look at audio. There is one of the original files. We're going to copy a new one up here today. So you copy the file, TFTP it. I have one here that we're going to TFTP up, and I'll show you how to do it. The second part of this is the voice XML, which I will now show how that works a little bit. Notepad. Here is a very simple voice XML that we can copy up to the router and put an application in. And all it does is plays that AU file off the flash, which in my case I have in the directory called audio. So two things, voice XML, AU file. Well, so the next part of this with the AU file, I did that and, it sounds okay. But again, it didn't really feel that authentic. And I thought, well, what's missing? It's those three little tones at the beginning. Those were missing from the audio file. All I had was Pat Fleet saying the number is disconnected. All right, so rabbit hole number, 3 or 4 now. I go down. I knew nothing about this stuff. And I come across special information tone, SIT. So these SIT tones were those in-band tones that were sent that would indicate to one side or the other some type of status. They are short and long durations. There's short and long, and there are 3 frequencies. I think there's 7 or 8 categories of them here. The one most commonly, I think, is the intercept that I was playing there. So I thought, well, how do I generate these SIT tones? Well, there's 3 of them in a particular frequency, duration. Can we use FFmpeg to do this? Let's take a look. So I put together this. Here's the tones. There's the durations. And yes, FFmpeg. Install it, use this, and this will generate all of these little tone files for you. There are, 8 of them here. And they sound the way they're supposed to sound. I think I'm missing a little bit of the padding in between the tones. It's close enough right now, so it's close enough for a demo, right? If you were doing this for real, it might have some issues. But that was step 2. Okay. Great. Now that we have a tone, we have the AU file. How do we combine them together? I thought just, copy/B in a DOS prompt binary, concatenate them, done. Nope, can't do that. They're audio files, so they have a particular structure, and we have to actually make them work better. So in comes another little. I wrote a library for this in Python. It was a script originally. And here's some Python that just takes those AU files and essentially concatenates the SIT file and the audio file together in the correct manner, makes it mono, and away you go. So now you've got the combined thing, which now we can take and put up on our router, which I generated that. And if we look, I'm using TFTP here, TFTP64. I have that file sitting on disk here. Here's the VXML. And here is the AU file. Let's take that one and let's copy it. I'll show you how to get it on the router. We will go copy TFTP flash. Name of the remote host. There's the machine I'm on. Source file name. The AU file. Destination. In my case, I'm going /audio/ the name of the AU. Boom. Let's do dir /audio. Looking good. There's the file. Now, let's look on apps. I have one out there from before, this SIT discounter out of service. I need to update that with this new audio file, so we are going to copy it over. Let's go back here and take a look. We have what I believe is the correct XML file. Same file name. But it has the location of that audio file, which I am pretty sure is correct. Let's copy it over and see what happens, shall we? Once again, I'll pop over to Putty so you can see it closer. Copy TFTP flash. There's the host name. Let me go grab the name of the file. Make sure I got the right file name. I do. Here's the host name. There's the XML file. Now we're going to put that in apps /that. Now I already have one on there. We're going to overwrite it. Now let's do a dir /apps. And we have the right date. It is today. Let's do a more on it just to make sure. And you know, we want to verify for sure. Let's grab that string and let's do a dir on that just to make sure it finds it. And there it is. All right. Got the audio file on disk, and we have the so the VXML and the audio file. So what do we need next? Let's do a show run on section application. This is going to be the VXML app. I already have it set up here, but as you can see, I named it blah, 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 blah. It is, I gave it a name. Same thing, just to keep it simple. And there's the pointer to the VXML on disk. I have some other ones on here. Once you have that, we can do a show run section. Let's go dial peer voice 4240. And here is the dial are the dial peers that I have serving that application out. I've got two of them, a VoIP one and a POTS one. And all you do is under the dial peer for VoIP, which is pretty much all you're going to need unless you're doing some analog stuff, is have that set up that way. You define the service, you point it to it, say outbound, and away you go. Audio file, voice XML, dial peer, application, those four main things. After I got all that working, I thought, you know what, this is a whole bunch of stuff. How can I make this easier for people? So I fired up Claude Code and I put together a Flask app, which that is the last piece here. It is up on my site. I'll include a link to it on the IndieDev Inditech website. But what you do, little Flask app, it's also in GitHub for you. You can host it locally if you want. Generate a sit tone. You pick which one you want. So let's go with the vacant code, and let's go one of the check number dial again, right? We're going to put that vacant code up front, and this is going to concatenate them together and put them together for you. Not only that, I'm going to generate the XML snippet for you here, and as long as you use the same directory I do under audio and upload it to there, it's going to generate it for you. Here's some little instructions on how to do it. And here is the application and the dial peer configuration for it. You should be able to copy and paste most of it around. So let's concatenate that together. Let's put that in my downloads folder. And let's see what it sounds like.
Please check the number and dial again.
And there you go. So now we have that one, and we can follow the same process here. We could upload that, drop it in your TFTP root directory locally, host it with TFTP D64, put it on your Linux box with it, TFTP, whatever you want to do. Copy it in, drop it on there, and away it goes. So now we have everything we need. I guess the one step here is, shall we test it out and see if it works? And do we need to fire up debug? Well, let me move over to this. Where's my OBS? Let's put on this camera. Move it around. I got a phone over here I can use. All right, cross your fingers.
We're sorry. The number you have dialed has been disconnected or is no longer in service. Please check the number and try your call again.
Haha. And it works. What else could we do? Well, there's all kinds of them. What was the other one I found? 4232 is the other one I assigned.
Abandon all hope, ye who dial here.
There's some funny ones there.
Abandon all hope, ye who dial here.
This one goes into a loop.
Abandon all hope, ye who dial here.
I need to put the sit code on that one, but there you go. There's a few examples of how to do it. The GitHub, I will show you finishing up here. Here is the GitHub. Some basic instructions. What do you have? The AU files, you could just use them as is. There are some iOS config examples up here I included. Same ones I use in the Flask app. There's the conversions, zip, and the web app. There's some zips too you can download. But anyways, there's the whole thing. I think that's it. Enjoy, and there'll be more war dialing coming up here in the near future. Now, if this works, laters.
We're sorry. The number you have dialed has been disconnected or is no longer in service. Please check the number and try your call again. We're sorry. The number you have dialed has been disconnected or is no longer in service. Please check the number and try your call again.